Hey YouTubers, so today I'm going to take a look at a cobweb antenna that I've purchased off eBay. It's called the AWK, that's A for Alpha, AWK Cobweb, and it's a 7-band cobweb antenna that's rated to take about 1,000 watts, which is well above what I'll ever used here. We're allowed to use up to 400 watts here in the UK, but typically I'm just going to be running either QRP or up to 100. So we're going to take a look at that. I'm going to put it together. It arrived from Poland yesterday. Cost about 200 UK or British sterling pounds, so about 200 with delivery from Poland. So it comes, let's start here. So this is the center spreader, all nicely machined, all ready to go. And then we'll go over to the fiberglass poles. So you can see they're yellow. I hope for a more discreet colour, to be honest. It looks like it's fiberglass, it's possibly been painted, so I don't know why they chose a yellow colour. I might have to see if I can do something about that. Make it blend in, paint it green or something like that, because it's going to be installed at the top of the garden, and I don't really want to be able to see it from the garden. I don't want other people to be able to see it. But when it's up in the air horizontally, I think it should. If you look at these trees I've got behind me here, it should blend in quite well with that. So that's the anticipation. So this antenna is 7-band, so it's going to cover quite a lot, and it's a really good match for the ICOM 7300, and the bands that it covers are basically from 20 meters up to 4 meters. So that's 20 meters, 17 meters, 15, 12, 10, 6, and then of course 4 meters. So it covers a lot, and you could just build this yourself. It's based on, you know, really well understood designs. It's supposed to be low noise, indeed very low noise, and it's got comparable performance to basically dedicated dipoles for each of those bands. And it's kind of hard to beat a dipole. Where when you get a dipole right, it's, you know, there's many antennas out there that you could try, but it's still quite a decent antenna. Of course, you've got much bigger beams. You know, you could use a hex beam, but the turning circumference of that is massive, and then you have to add rotators into the mix. This is omnidirectional, compact. I think its total spread is 2.7 meters. I'll correct that if it's wrong. I'll also put a link into this product as well, so you can see where I got it from on eBay. So yeah, it was just a lot easier to buy it ready-made than to manufacture it myself. Of course, I could have brought all the individual bits. I could have built the balance box. I could have, you know, got the fiberglass spreaders, machining the metal. I don't have any tools for that, so that would have been a lot harder. So what I'm going to do is try and put this together. I've not got many instructions, so let's see what we do have. Basically got some photocopies of various diagrams, and I'm hoping these are going to be self-explanatory enough. I fear that the hardest thing with this antenna is actually going to be tuning the wire elements. I think that's going to be the toughest bit. Actually putting it together mechanically hopefully won't present too many issues, but yeah, I think when we get to the tuning stage, that's when it's going to be pretty time consuming. But let's see what it does out of the box. I'm going to put the antenna analyzer on it later, and we'll be able to see kind of how it performs out of the box, and whether I need to do too much to it. Maybe I don't, who knows. Okay, here we are. So I finally put it all together. So this is the cobweb. You can see it looks pretty big on the ground, but certainly a lot smaller than the hex beam. It's been raining for most of the day, so I've not really been able to kind of track how much time I've spent on it. I've just been nipping out when the rain's eased off a bit. You can see it started again. I thought it eased off. I'd actually gone inside to do some 6 meter sporadic E stuff, but yeah, hey ho. So yeah, first thoughts are it looks generally pretty well built, to be honest. I like the center spreader. That's better than I could have engineered myself. Balance box looks pretty decent. Whether it needs additional weatherproofing, I'm not too sure right now. Probably. I think I will do that just to be on the safe side. elements look decent. What else is there? Yeah, probably minor criticism would be just the choice of colour. You can see the yellow fiberglass poles there. Yeah, all four of the major ends are bright yellow, and possibly also the use of the green, but I think up in the air you're not going to notice that. I'm also hoping the yellow won't be too visible up in the air, otherwise I'm going to have to take those off and give them a lick of I don't know, green marine paint or something like that to change the colour. But yeah, pretty minor criticisms, to be honest. Certainly better than I could have built myself, and that's pretty much kind of what I was hoping for. As to performance, don't really know right now. I've not got it up on the mast. I've got the mast ready to go. I'm going to use a tripod support initially, and I have got guy ropes. I've been having problems recently with foxes chewing through the guy ropes, which has been a bit of a nightmare. That's how my last mast came down, and why I have this replacement antenna here, because they brought it down twice, and on the second go they broke it fully. So yeah, I'm gonna see how I get on. My thinking is, if I can use the tripod as well as the guy ropes, then at least if they chew through one of the guys, it's still going to be held up by the tripod. And it's not going to come crashing back down to the ground. Okay, so it's now attached to the mast. Not too difficult to get that done, actually. Pretty straightforward. You can see the total width of it now. And the mast is about 5 meters high, so it's not particularly high. Apparently the cobwebs do all right from like 4 meters up. So I'm going to try a very kind of moderate height. You know, it's certainly a lot easier to guy if it's just kept at 5. So you can see, if we just go in a bit, these are the ends of the driven elements. Driven elements are obviously the black wire there, and you can see helpfully we've got this silicone in place, so that's going to allow us to quickly adjust the length either way, basically. So if we need to add a bit more, we can. If we need to trim some back, we can just fold it back, and yeah, hopefully we can trim it well enough just using that. I believe it's already cut for the bands. I mean, it must be roughly cut for the bands. I don't know where he centered it. It could possibly be in the middle of the band. Then I've got that decision to make, you know, is it flat enough that I can use it without an ATU, or do I trim it for, say, the data bands or SSB, or, you know, where in the band do I want to be most active, and then use the ATU to kind of smooth out in between. So yeah, that's where we're at the moment. So I'm about to hoist it up in the air. It's quite heavy on the end, so we'll see how that goes.
Inside of the focus, taking frames by the second, like the times that are frozen on the carpet, like an ocean with your friends by your side. Every moment you admire with the sparkle in your eye, a flash of light and they all stop moving. Every memory successfully captured by impulsion.
So you just witnessed the first failure of hoisting up the mast. So I'd forgotten to do a few things, actually. When we look at the spreader block, you'll notice there's these kind of screws, nuts and then screws that hold the kind of spreaders in place, and they're here. We'll get back to that, and here. So there's 3 fixing points. It looks like the other 2 should have fixing points, and I've got the screws for them, but they've not finished the machining. So you can see they've made the pilot, but they've not drilled it through. And I think on the other side it's just I don't know if you can see that. That's an impossible angle, but basically it's blank. And it's the same over here. It's just missing the fixing point. Again, on the other side we've got the pilot, so we could do it ourselves. I don't really fancy doing that right now. I could probably get the drill out and do it, to be honest, but yeah, I think that's why it collapsed. And also I'd only fixed this this bottom spreader in place, so these other two up here weren't actually fixed with these holding nuts, so that's why it collapsed when it was being hoisted into the air. It's obviously pretty heavy. It's hard to get some kind of leverage on it, being a 5-meter pole. So in the end, I stuck it in the soil at the end of the near the compost heap there, and that seemed to work. I could then just about leverage it up. But yeah, not the most successful hoist of the mast. You kind of want to get it up quickly and then fix it in place, but sometimes things go wrong, don't they? So anyway, let's try take two. Take two. It's up in the air now, as you can see, 5 meters high above the ground. Yeah, doesn't look too bad now it's up in the air. I can't even really see the yellow, even against the grey sky. It just kind of blends in. Huh. Yeah, okay, well that's definitely good. As you can see, it's a bit of a lash up. So I'm using this big tripod that's meant for my pump up mast that goes up to 14 meters. Slightly overkill, but it helps to get the pole up without fixing the guy ropes just while I test. Hang on, let me give the lens a little clean. There we go. Back to HD. So yeah, a bit of a lash up. I've used cable ties, which is pretty much my favourite go-to for quick lash ups, especially when portable. So I've just fixed it in several places to the tripod itself. I'm going to use the guys later, but just for the sake of testing and looking at it initially, I just wanted to kind of fix it temporarily in place without messing around with guys, only to take them down afterwards to bring the whole thing back down again. Yeah, so that's it. So let's get the analyzer on and see what it says. And cue rain. It's just one of those days today, but I'm sticking it out in the t-shirt. Okay, I'm going to have to beat a hasty retreat here. The rain's really picked up, as you can see. So I have actually relented, and I've guided the mast now. So I'm going to leave it overnight. It's got the tripod and the mast. I'm going to have to come back to the antenna analyzer when it's not torrentially raining, but it's up and we'll leave it for another day. Welcome to day 2. It's finally stopped raining, and now we're going to try and test the Cobweb antenna, and we're going to see how it performs across the several bands and whether it needs any tuning or not. So it never stopped raining yesterday, so I was glad I retreated, because it just hammered it down and continually torrentially rained all night basically. Finally stopped today, a little bit windy, but as you can see, the cobweb is still up in the air, which is good. So it survived one night. Certainly it doesn't seem to move too much in the wind as well. There's a bit of a breeze, bit of a strong breeze, gusty at times, but it seems pretty stationary there, so happy about that. Additionally, the foxes don't seem to have chewed for anything overnight. I put the coax up like this to keep it off the ground and hopefully keep the foxes away from it. Okay, welcome to the shack. We're indoors, away from the elements. So I've got the antenna connected. So the cobweb's connected via this dodgy RG58 coax cable. And I'm running the NanoVNA analyser on it at the moment. This is a new analyser to me, so I'm still getting to grips with it. I've got it scanning across the 20 meter band at the moment. What I'm going to do is I'm going to flip to some software on my computer. I've basically connected the NanoVNA to my PC, and I'm running what is it called? NanoVNA Saver software, and it lets me control the NanoVNA remotely via the USB cable, and I can see a lot more information. So you can see it there. What I'll do is I'll switch over to some screen recording so we capture everything in a much better way. Okay, welcome to NanoVNA Saver. This is software that's in its kind of beta stage. You can see the version number 0.3.5. It's a release candidate. It's not perfect. There's a few bugs that I've managed to make it crash a few times. However, it's pretty useful. It does show you a lot of information here, most of which I don't understand, to be quite honest, but the thing I'm really interested in is this SWR sweep across the different bands. So you can see at the moment we're trained on the 20 meter band, and we're scanning from 14 meg to 14.35 megahertz. You can see the start and the stop frequencies set here, and the center frequencies and the spans you want to use. So, as you know, I'm connected to the Cobweb Antenna 7 band. It is obviously set up for 20 meters, and you can see the lowest SWR is around this point here. So this is about 14.2 megahertz. So pretty good for SSB. You can see the SWR is 1.169 here. Pretty good, and it's pretty good throughout actually. No, that being said, it does creep up quite a lot. At the start of the band it's up to about 2.0, and then it gradually goes down till we get to about 14.71, which will be the FT8 frequency in SWJTX. So you can see here it's about 1.6, very usable. I can certainly tune that out with the internal tuner in the ICOM 7300. So that's pretty good. Not too bad, not too shabby. And, you know, it is centered in a good segment of the band. It's going to be good for kind of SSB contacts and contests that occur. And that's mostly what I'm going to use 20 meter voice for, is entering contests, or more likely just picking off some DX that are in the contest by chance. So not perfect, little bit narrow, as you can see here. And this is pretty much a feature of most of the bands that the Cobweb supports. It's pretty narrow. The dip is not very flat, basically. So that was 20 meters. So let's go to, hang on, let's check this. Okay, it's just doing a single sweep, I see. So what we want to do is set this to a continuous sweep, and we'll just set the band sweep. No, we'll change this 20 meters. So this is where you change the band, and you can see we've got all the bands that it supports here, and it goes right up to 1370 meters. So pretty extensive, but we're just interested in 20. We'll set the band sweep, we'll go back, and we'll hit sweep. Now this is doing a continuous sweep across 20 meters, and it's updating these figures as we go. It's obviously a bit more reliable than a single sweep, which, you know, could be kind of influenced by any number of things. So I prefer to do a continuous, or at least take the average of 3 sweeps. But you can see the results are pretty similar, about 1.6 SWR on 14.07. So that's kind of roughly the FT8 frequency for 20 meters. Right, let's stop that, and we'll go back to sweep settings, and we'll change this to 17 meters. So we'll set the band sweep, we'll close this, we'll hit sweep, and you can see it's uploaded, or more to the point, it's updated. We're now scanning across 17 meters. So you can see the SWR here is looking pretty good, actually. So the FT8 frequency is 18.104 on 17 meters. So if we go vaguely in that territory, here we go. So we're now trained on the FT8 frequency, and you can see the SWR is very good actually, 1.08. At its lowest point, it seems to be most resonant here. So, you know, overall, I'm not too fussed. The SWR is pretty low across the whole band. It peaks up here at the end of the band at 1.49, about 1.5. So, you know, once again, you can tune that out. So pretty good across 17 meters. Pretty good indeed. So we'll stop that. Well, now go back to sweep settings. We'll change it to 15 meters. And we'll hit set band sweep. And we'll hit sweep again. Here we go. So what are we looking at here? So the center frequency for 15 meters FT8 is 21.091. So let's have a look. Yes, pretty much as good as I can get it. So it's focused in on the FT8 frequency. SWR of about 1.6, not fantastic. I could tune the cobweb. However, this kind of roughly centre of the band minimum is pretty good, because that means I'll be able to use SSB as well during contests or whatever. So yeah, pretty good. At peaks, you know, bottom of the band, you're looking at about SWR of 2, and then across you can see it dips. What's the dip frequency? 21.190. Let's call it now 190. And then it sharply rises, but not by much. You know, this is all very tunable. And at the end of the band, it's 2.1, almost 2.2 SWR. So a little bit high. Still, I think most internal ATUs should be able to tune that out and flatten it a bit. It's not going to be a problem for what I'm going to be using it for. I'm not going to be running an amplifier into it, so I don't need to worry too much about that. So pretty good. Let's stop that. Let's go up in frequency. Up we go, 12 meters. Set the band sweep, and let's run that. So to be honest, I don't really use 12 meters much. It's nice to have it, especially when the solar cycle improves, but right now, kind of at the bottom, the only activity I'm really likely to see, I would imagine, is probably sporadic E during the summer. But then again, it's a very underutilized band, so not too much going on here. So looking at my reference on the other screen, which you can't see, I can see the center spot frequency for FT8 activity is 24.915. So let's find that. 915. There we go. Well, pretty good actually. So the SWR is 1.3 on 12 meters on the FT8 frequency. So far, pretty good actually, considering I've done no tuning to the 7-band cobweb at all yet. It's looking pretty good. And you can see the minimum point here is towards the end of the band, and then it's almost like 1.0. It's as good as we can really hope. So pretty good, especially in the upper kind of SSB segment of the band. It could be quite useful come the upturn in the solar cycle, but right now not much activity, I'm sure. Let's hit stop. Got a few more bands to do. Where are we going? We're going up to 10 meters. Okay, here we go. We've got the update. So we're now swooping across the whole of 10 meters. So what are we looking at for the FT8 center spot frequency? 28.074. Pretty much as good as I can get it in these kind of small steps here. Looking at an SWR of about 2.2, that's probably the worst yet actually. So 10 meter band, and you can see the dip point is super narrow. It's not got very much bandwidth on this at all. Certainly resonant in the band, but you know, this drops right down. Not necessarily in a bad location, actually. 28.442. So, you know, I kind of, yeah, it's well in the SSB part of the 10 meter band, and certainly quite a lot of activity typically around that area. So yeah, that could be good during, you know, upturn in the solar cycle, but usable throughout with ATU, whether internal or external. Not rising particularly high, not great in the CW segment though, 2.3. You know, it gets better and better and better, but then coming out, it's not much bandwidth here at all, is there? So what are we out there? So let's take that point. That's 28.221. And that's 28.7. So, yeah, there's a bit to play with, but you can see this point here is just super narrow indeed. But I'm complaining. It's an incredible antenna for what it does. You know, I'm not going to get the kind of broad bandwidth I want unless I dedicate an antenna to 10 meters. So pretty good. Let's stop that and let's go higher up into VHF. So let's choose 6 meters. We'll set that. And you can see when we set the band sweep, it sets all of these parameters automatically. So the start frequency, the stop, and the center, and the total span. So let's hit sweep. What have we got here? So we've got a good low here, about 50.320, which is quite useful actually, because the center spot frequency for FT8, or the center of activity for FT8, is what am I saying? It's 50.313. So yeah, I can't put it in exactly, but it's pretty much bang on the center frequency for FT8. Once again, pretty narrow. What's the max we're looking at the start of the band? 1.4, very usable. Then it rises here. So this is about 1.7. You know, once again, you could tune this out of an ATU. It's, once again, it's 6 meters. You're only really looking at it sporadically in the summer. With this kind of antenna, you know, you'd want a dedicated back beam for 6 meters if you wanted to use it seriously, and you certainly wouldn't be running, you know, 20 or 30 meters of RG58 coax up to the Cobweb antenna. You'd want something with a bit more gain. However, pretty usable for FT8 during the sporadic heat season. So looking pretty good there. Let's stop that. Let's go back and let's look at the last band, which is 4 meters. We'll set the band sweep. Yeah, and then we'll hit sweep and we'll see what we've got. So, what is the center spot frequency for FT8 on the 4 meter band? Is 70.100. There we go. So an SWR of 1.125. That's pretty good indeed. It's pretty broadband actually on this band, and I'm wondering if that's just to do with the coax that's being used. It's probably very high loss. In fact, it will be very high loss on 70 megahertz. So we might just be getting a kind of perfect 50 ohm return. So I treat this reading with suspicion, but nonetheless, you can see on the other bands it's looking very good. It's performing where it should. We can have a look at some of the other frequencies or other bands that it doesn't support. So if we go to 30 meters, set the band sweep, and we'll hit sweep. So it's pretty much the same across the entire 30 meter band, and it's an SWR of 4 or more basically. So yeah, that's not where it was intended to work, but interesting to see nonetheless. Sometimes you can eke out the odd weird band that isn't officially supported, but not in this instance. I've had a look before on 40, 60, 80, and obviously top band, and it's the same old thing, a very high SWR as you would expect. But you know, going back to the bands of operation, like 20 meters, looks pretty good. You know, that's a very usable SWR. Could I tweak it? Yeah, I certainly could. Do I want to tweak it? I don't think I can be bothered. Looking at the SWR, it's looking pretty good throughout. And you know, at different times, I'm going to operate in different parts of the band. I don't only operate FT8. I quite like to get on SSB as well. So, you know, I don't necessarily want to train the lowest point of resonance to the FT8 frequency, which is typically quite low in the band. You know, normally just after Morse. I want it kind of somewhere around it. SSB, to be fair, middle of the band is good. So pretty good throughout. Pretty good. Certainly impressed. And hopefully you can see the NanoVNA in action here as well. It's been quite good to connect it to NanoVNA Saver, this program, and then control it using this. It's obviously much more readable. It's it's easier to use. It's easier to change settings. The NanoVNA screen is quite small, so you know, with my sausage fingers, it's kind of hard to select the right menu options and all of that stuff. But pretty useful. Pretty interesting information, and it's all kind of as we would expect. So that, you know, the antenna is as advertised, really. So I did a bit of FT8 testing earlier. So let's open up log4OM. What have we got? So today, yeah, I ran it on 20 meters. You can see just working across Europe. I did get quite a few spots in other places. So if we go back actually, so here we're looking at pskreporter.info, very useful website for any data mode operating. I found it once when I was operating PSK31 back in the day. Been using it ever since, and what we're looking at here is where I've been heard, where I've been spotted around the world, basically. So I operated for maybe a total of about an hour, a number of hours ago now, then had some lunch and then operated again. So not too much operating, mostly on 20 meters, and then moving up to 17, 15, and having a look on 10 meters as well. So you can see pretty good coverage actually. Pretty good coverage indeed. You know, remember this cobweb's only 5 meters above the ground, but I'm being heard quite far out. You know, this guy over here, Russian station, he was 6,491 kilometers away. And you can see relatively good coverage of the east coast here. It was early in the day, so I'm assuming if I operated now, I'd probably be spotted in, you know, I'd be going further west by now, I imagine. So pretty good coverage, but that just gives you a quick idea of how the antenna's performing. Obviously your results will vary. Each day the results are going to vary depending on conditions, but overall pretty happy with that. You know, certainly around Europe, it's got very good coverage. You can see it's omnidirectional. It's anywhere where there's a landmass, I'm being heard basically, even to some of my bad directions, which is to the south here because I have rising ground that way. But you can see there's many spots across Europe. So that's a bit of a video about the Cobweb antenna that I've put up. So you've seen the whole process of me building it, hoisting it up in the air rather unprofessionally, but it got there, and then putting the analyzer on it, testing it, seeing where it's resonant, and all in all, it's resonant in all the right places. It's behaving as expected. So I guess time will tell how well it really performs. You know, I've only very briefly used it on the radio just for an hour or so, but it's putting out a signal, and it's receiving pretty well as well. A bit of noise I noticed. I don't know if that's coax pickup. I've got quite a long run of coax leading to the top of the garden. I've also not had an antenna in that exact spot before, so maybe it's nearer to a noise source. Once again, maybe that's something that I'll find out about in time and be able to resolve. But all in all, so far impressions very good, very well built, very easy to put together, and all trimmed and set up for you. So not too much to do on the kind of, you know, making it resonant in the intended bands. It's pretty much there, just out of the box. Certainly at the small 5 meter height. I'm assuming that obviously when I get it up in the air, things will change. But that's all I can say for now. So you have to stay tuned to see what other videos pop up and what else I might be able to tell you about it. And the NanoVNA, I do intend to make a bigger video on NanoVNA and just cover it in more depth, because it's a very good analyzer for about 30 UK pounds, which is about $40 US. So very, very cheap and does a lot indeed. A lot to cover there. Anyway, I wish you 73 for now, and thanks for watching.